Well, we're back on the case this week. Hey, Chezzy. We're putting the last temporary wall up at the top of this construction. So the beam that we're replacing first is the long span downstairs under a vaulted first floor on one side and under the second floor on this side. So we haven't got a temp wall on either side of the load here because to be outside, we're not under anything else. If that doesn't make any sense to you, then you're maybe in over your head watching this thing. But this is our uppermost temp wall. We're going to take this half of the roof's weight and the weight of this exterior wall off of the beam downstairs by putting it on this temp wall and thereby on the temp wall under this temp wall and then on the joists of the first floor, which are back onto a steel beam in the basement that we're not going to disturb, but for redundancy's sake, we're under this location to the basement floor again, as well as under the weight of that roof out there with a temp wall on the first floor that's above a temp wall in the basement, even though it's on the joists in the first floor that are on the steel beam in the basement that we're also not disturbing again. Basement temp walls are totally redundant, but I really feel good about them, and we'll use that lumber when we're all done here to construct some of the additional spaces that are a part of this project. So we put a 2x12 up on this one, and now we went with 16-footer here, 16-foot 2x4 there, and we've used 16-foot plate lengths in the first and the basement floors. So, and we've started at the wall with the same sort of offset before we start a 16-inch on center layout, because we understand that to be where the framing layout is in the house overall, and that part is something that the builder got correctly. We're either directly on from rafter to stud to floor joist to stud to floor joist, completely aligned, or in some cases we're to the left or to the right of the previous. And that way you can route, especially in an HVAC house like this one, you can route those systems cleanly through multiple floors without coming through a joist bay or a rafter bay or a stud bay and slamming into the end of a corresponding joist or rafter or stud that's right in the middle of that bay and being, it being impossible to continue. So since our layout is quite perfectly stacked, we could be sure of where the rafters were, and we put those layouts on these, plates before we went up on the ceiling with them. So there's pencil lines there, and we're on the left of the pencil line, and we've nailed into this ceiling. Now, you don't normally have to nail the whole thing completely, because when it's flat, you're just setting your weight and your load on top of it. But because we're in an angle and, there's the opportunity for things to move laterally, for lack of a better way of putting it, we want to trust the tensile strength of the shear strength of the nails. So all those nails are really what's loaded with this roof directly, and then it's translated to the 2x12 and translated to the 2x4 and then down to the flat floor. And this is the best you can do with an angled surface like this. We went with the 2x12 because I also want to take care not to crush into this popcorn ceiling right now. They don't love it and they want to get rid of it. But if we went with a 2x4 or a 2x6, we're just putting this much pressure on less surface area, and then maybe you see that, where in this case, whatever we see left over will be the minimum possible, because it's the biggest dimension of lumber that you can buy. Tim's putting his studs in place. And then I'll show you how somebody thought we should put together joist hangers downstairs, which won't be what we're doing when we put them back together now, because it will not pass structural inspection, because they are not approved hardware. I am digging them all out of these hangers because we're going to try to move this beam out of here now after we remove the jacks that it's on. There's a pair of jack studs on this end and a pair of jack studs on that end. And what we'll do is, now they're probably so it was nailed in through this king. So when we're done taking all of the hanger hardware out, so it would fall down from there if the jacks weren't under it, then I'll open this gap at the end and slice all those nails off. And you follow my thinking here, we're still physically bearing on these, and we'll slice, if there's nails back here, we'll slice those, off. And then there'll be no fasteners. It'll just be the weight of this beam now on this pair of jacks on both ends. And that will mean that if I start cutting into them, straight into them, I can start and I can feel probably a bit of a pinch from the weight of the beam, but we can relieve that with something one way or another, and we can relieve then the pinch on the blade. If we can't relieve that, it's because we got more load on that than we planned on, and at that point we are not in over our head because we still got structural components underneath that beam. We have the opportunity to add things under that beam. Just again, redundant safety, abundance of safety, but in the end, it shouldn't be necessary. We should be able to just slice those jacks, and when we're ready, take the weight of the beam out. In fact, we may even take it out in layers because there's only like one nail here and one nail up there, and like someone didn't understand how to laminate. So since there's so few fasteners, we'll be able to pull this apart and reach up in there maybe. Maybe we'll just take one layer out first and then the second layer out after that. We don't know. But for now, I gotta show you the nails. Those are, hang on. Those are roofing nails and like 16 penny common nails. And they're just kind of mix and match. And the roofing nails that have come out have been 1.25 inches. So pretty much completely unprofessional trash work of putting that in like that. Certainly better than nothing. At least it looks like a fastener in every opening, which is a best practice and actually code compliant. But other than that, it's the wrong hardware completely. But I will say, once again, as we ended up last week, the way that things were put together was in such a way that makes it very easy to take them apart. So thanks so much, General Contractor Guy from 2001. Well, that went relatively smoothly. We did, use an abundance of safety. Try not to just yank everything out in one fell swoop. I ended up digging some nails out. In this case, I cut those off. We took one layer and then we took the second layer. We ran into not knowing or not realizing that there were nails towed down from above into the top. There were hanger nails that were enough into the side of the beam hanging there to keep us from being able to really pull it down easily. And so we did a bunch of back and forth to make sure that it was supported while we got rid of some more connections. And then we came back to see if it was loose enough. No, and then we went back to supporting it and worked on some more connections. Because the last thing you want is for it to come crashing out of here. Even though we had those sticks across here to kind of stop it soon, I still don't want to see them hit. You never know what may happen. Something could break. So you just want to limit how violent anything could get. And so then we had the architect in here to confirm a few things. One of the unfortunate things that we discovered was that this center line of this wall and these beams and this upstairs wall and everything, the reason for this discrepancy where the second floor overhangs the first is because they deliberately moved that all over. And so your beam in the basement is at this plane, and this upper wall and these beams and these posts and their bearing are about a foot off of the steel in the basement. And I figured that out because I looked in this cold air return, which normally your cold air returns are in front of your windows on the outside of the house, but this is a cold air return and I could see the angled face of it and I could see that wire going down the center line of it. But I went downstairs just to kind of keep it, this is where you discover things like this. I'm checking, I'm thinking, I'm checking, I'm thinking. And lo and behold, I see this return, but it isn't tipping there. It doesn't tip till here, which is what I'm looking at and seeing upstairs. And so I check and see that the wire coming down is this one. And right, your center line's off the center line of the beam, 12 inches. So, and then the other thing is, let me try to line up so you can see it. You've got a joist layout here on 16-inch center, 16-inch center, 16-inch center, 16-inch center. But you got an extra here and you got an extra there. And the reason for those is so that you've got more translation of the load from just the subfloor. There's a plate on top of it and a couple jacks that take this beam. And over here there's a plate and a couple of jacks that take the end of this beam. They're really on this side of this beam over here and over here. However, we really should have even more. We should have a couple more joists in there, and they should kind of be directly under the jacks that are directly under the end of the beam. So you got solid beam over to down to solid pair of jacks down to solid joist, thicknesses to this steel, even though they're cantilevered over. So we'll likely have to send some 2x10s over there. We'll probably pull this cold air return down and probably might even omit it or take it back over to here. At a certain point, we're going to have to roll it back enough to get the lumber in there, and the lumber's going to have to be there. And so I guess if we're going to shorten it when we're all done, maybe we'll start here. No, I still need the room to get the lumber in there. We're going to have to cross this bridge when we come to it. But we need to have solid structural elements for that to get to the beam and to cantilever over. And if you look at our original drawing, it doesn't show that. It shows everything stacked. And so I don't know what the big idea with an extra foot of floor space on the second floor was, but it added a lot of complexity over there. It should have added more complexity than there was here. And again, don't know what the goals were, but we got this stuff out. Now, the architect was here and he also said, given the way that everything's kind of constructed, questionably, this is hanging in space, this wall, based on the connections at these rafters here and the other end of the lower end of the rafters for the second floor, and assuming that that's all kind of copacetic and well anchored. But again, is that what this guy who built this place was all about? Not really. So before we go cutting the rest of the rim out of here, he said it would be ideal because your floor is supported, but you don't want to see the wall come down at all or for anything to happen there. So we have to take the OSB off anyway to get the beam in. We're going to measure from the bottom of the joist up the 18 inches that we need, which we've done. We'll snap our line on the OSB, cut that, and take the OSB covering off. Then we can see a little bit more what's going on in the wall, but we could also, because again, our layouts, look at our temp walls are right on the joist, and there's red lines in the sheathing, which is likely on the layout. Hopefully our studs in the upstairs wall are right there, and we can go right from the side of them and right down to the floor and be on the side of this temporary wall. And thereby we've got a deliberate and active support to each one of the studs specifically in that wall, in addition to holding up these rafters in the way that they're attached to that wall. Just a little bit more of an insurance policy. Then we'll take the rest of the rim down. Then we'll take this abutment or this bulkhead down and out of the way. We'll get the bearing right in the wall, right in there, made of several layers of 2x4 for our new beam at the right elevation, and then we can tear this down over here too. And at some point we'll quit because we're not supported over there. We'll saw this right cleanly off and just leave the rest of it to be removed when we get to this point over here. So for now, we're gonna uncover that upstairs from out here, and then maybe we'll have to get some lumber to truss over to there. And then tomorrow we can finish tearing that stuff down and start to construct rather than destruct. Okay, well, we ran into a problem yesterday that won't be that big of a deal, but the reason for the overhang in the house on the second floor over here, somebody decided to make it bigger, and so the house isn't what's shown in the original blueprint, in the sense that the second floor outside wall isn't right on top of this beam downstairs, and therefore the beam under the edge of it and the bearing post or short wall that was there wasn't here. It's over here, right? So maybe I've said that, but there's the cold air return vertical that was right in that wall, and here we are in the sort of full bay that was left for a conventionally sized cold air return between bearing on the left and bearing on the right. But again, about 12 inches off center here. So we determined that 110 inch long stick, and I'm gonna help, oops, I'm gonna bang my head on that, and I'm gonna help Tim, oh, we have no chair. We're gonna make sure that the 2x10s we cut at this length can be theoretically sent up and over the beam and placed, there we go, and placed, this is highly technical, here we go. We wanna get to the sill plate over here. Oopsie. Okay, so we don't want to pull ourselves. We obviously don't want to fall in down there. We're going to put them in flat. We're going to turn them up. And we're going to be roughly in the center with 4 2x10s, center of this bay. We're going to be on the sill a couple of inches. We're on that plate a couple of inches. I think 110 will do it. And the goal is to have a gap behind us here to have a little bit of insulation and not to necessarily thermally bridge right into wood for any reason. It's just the best practice. It wouldn't freeze this basement out, but it's going to be a lot more solid wood than this. The other thing that we need to deal with is going in and going up. So we pulled the cold air return, which is done by just covering 2 joists with steel. We needed the room here for the angle of attack to go up flat and turn. So with each consecutive layer, we lose the room to, the first one can go up totally flat and then turn up. Maybe the second one can go up flat and turn up. Then we won't be able to go fully flat with the third and the fourth layers. They'll have to be kind of at an angle. And I'm gonna be very careful to see what the actual joist height, right where we're gonna come tight on this beam is. And I'm gonna take that to inform, the other end and think of it as being the same, because I may rip a little off of these new 2x10s to make the turning up tightly possible. To vertical, because adjacent corner to adjacent corner were a bigger dimension than flat side to flat side. If you remember your geometry, your hypotenuse is longer than the second longest side of a right triangle. So we've also cut back the nails. There are no nails, luckily. Any of this was all carpet before, so no nails. But starting at the cold air return in this room coming over, that was hardwood and there are some nails there, so we're gonna cut those down as well. And we're trying to get 4 layers in here, and the 4 layers are literally aligned to the 2 jacks under our new big span, and then the other 2 jacks under our new short span, and therefore we've got solid beam to solid jack to a plate just long enough to catch all 4 of them, to a subfloor repair on that hole, to 1, 2, 3, 4 layers of a beam that's nice and heavy in here. And someday they want to put something really big and crazy downstairs, like an enormous heavy bag, which something like that, they have this extra beam. But we're going to make it easy to install more than we're going to make it a perfect tight fit, because the perfect tight fit will be a nightmare to put up. And we're going to try and do that as quick as possible, then go back to working upstairs. So we need a longer bar for leverage to get these turned up vertically in the basement. So we turned around and came upstairs, and now we're making sure that we can cut what's left of the rim joist off of this floor system, because they spiked through the first layer into the end grain of all the joists. Then they covered it with a second layer, and they applied that with some spikes and stuff too. And if you look at the cross section I sketched up over here, the problem is we can't be sure of the way that it was constructed. It should have been either rafters going into the second floor wall with a good amount of attachment, or a ledger. In this case, it had to be a ledger applied because the whole wall was sheathed with OSB, because their joist that was here, the rim joist for this floor, that we're actually talking about removing, stuck out enough, just like the rim joist did down here, that it was underneath the edge of the sheathing. They did the same thing here. So they couldn't have left the sheathing off, or the drywall wouldn't have sat flat. So it's fully sheathed. We can't reach up and feel of anything in here, like hoping that it was attached like that. It's likely on a ledger, but if we want to make sure that it can be completely removed and we don't get collateral, the weight of this section of wall, because the rafters up here on the second floor roof were spiked, toenailed down into the top plate of this roof. So in theory, this wall component could slide off of those nail tips, because they're not screws, there's really nothing, promoting attachment. And if this isn't well attached here, these support walls that we used won't hold this up. It could slide off the ends of those nails. If there's only a few nails holding this ledger, it could sort of migrate down here. And I'm not saying it's going to come through us like a guillotine blade, but if it sags up in the middle or moves as a collateral effect of losing this attachment, then we got to fix that. And you can pick it up with my shores and stuff, but then they're in the way of what we're trying to do afterward. So we got to make sure as we take this apart that we don't lose any ground. And it would be because the person that built this place was really not into using a lot of fasteners, like 1, 2, 3 here, where there should have been half a dozen or more. So because of that, we're thinking about what that would mean for taking it for granted and, counting on it to be the way that it should be put together. So once those are free, I'm going to cut up between these shores. We put the shores right on that joist layout. That's right on the floor joist layout. So we're not on this 1/2 inch, if you can believe it, subfloor with those. They're right on the edge of a joist. And then we'll slice it now that it's free. And then I'll relax those, and I'll see if my cut opens up toward, if things are moving down, creaking and groaning, and the cut's opening, we know that we're going to have that problem. So then we will have to jump from every one of these support wall studs up onto the side of every one of the wall studs up there that's going to stay, and triangulate and basically truss or otherwise shore that up first. And then we can try relaxing these. And when we see that that's fixed our problem, then we have total confidence we can remove the rest of this thing. And again, we're going to try and have an abundance of safety here. Okay, so that went fairly smooth, and I haven't seen any movement. We actually established that the depth of the beam to be at the back of the drywall upstairs was to the depth of these notches that was here. So we get to put a nice square end on all the joists, which is awesome. And tomorrow we'll cut that subfloor, take that upstairs wall plate and the lower portion of the studs away from the drywall cleanly is the idea. And break down that little bit of bearing there, this little bit of bearing here, and probably rebuild some. We got a trailer to haul all our trash away the day after, the last day this week, and that's kind of all we can accomplish with the way that works that day. And then we can put things together next week, put our beams and stuff up. These are our old beam pieces. That's something that once we know where the bearing is, we know our absolute length of our beam layers, and they can be cross-cut in the driveway and be ready to go in here. Oh, and I can bring my big bar and straighten these out, put them in the right location. Tim can patch his subfloor, and that will be a factor of then being able to come up with our bearing. And I was talking to him about how, see, we're gonna butt our beams end to end, so we don't have the opportunity for a full king to control the tip just for assembly purposes. And if we were to put one in, then we've added 3 inches to overall width of this post, but we're trying to mitigate the size of this post because we can always add to it, but we can't take away. So I got to thinking, like, it's gonna be hard to put just 2 random jacks up and put those layers here, and it'll be buckling and moving all around. We're gonna probably have to do something where because the thing about the tip, it'll be controlled in the application of the joist hanger on all the beam, or on all the joists to the beam, and then thereby, you know, it can't tip back and forth. So we'll probably have to put our layers up on a bearing that won't allow it to tip down there, and it'll be a little tippy here, and we'll do some other stuff to hold it. Maybe we'll get a little help, but then we can put at least a joist hanger on this end and a joist hanger on the other, maybe one in the middle for good measure. And then we've got everything locked into position. We put our other 2 layers up, you know, putting it together as we go, and then finish all the hangers, finish all the hanger screws. Kind of a lot of busy work there. But then we'll be really sitting pretty. And then turn around, replicate that process over here. And again, if we hadn't ever done this before, we'd start small and then go to the big. We went with the big here. All things considered, it'll be quick and easy to replicate what we did with all the knowledge that we've got. We can sort of trust things a little bit better and move more quickly, and everything's smaller. And then we'll get that all done, and then we can start the fun part, which is, at least in this area, we've got some other work to do elsewhere in the house, but we got to get our plumbing, drains and stuff locked in. We're going to do a pot filler over there and some other systems in the wall, the electricity, and then it can get covered. Then the cabinets come in and get placed. So we got to plan all that, and then the cabinets can be getting made, and we'll jump into systems in this outside wall and maybe start adding some other things. But we're going to try and keep the kitchen running as long as possible here, and it would be nice to be able to sort of, you know, when we shut that kitchen down, have it very soon where the new one is sort of at least functional. Maybe you're in here on subfloor, maybe the countertops are just plywood placeholders or something, but, you know, hopefully not go more than 2 weeks maximum without a functional kitchen here, and before everybody goes back to work and stuff, because we're off as teachers. They're off for the summer right now, which makes it easier. As soon as you have to go back to work and stuff, it makes it kind of hard to live around. So we're gonna do what we can for that. Still already loving the sight lines without this beam hanging down in here. Can't wait to get the plastic wall. It'll make a really nice reveal when it's all done up. You can see it from in here, but when you take that plastic wall down, oh yeah, chef's kiss. Can't wait. All right, Tim's getting the rest of this cut to the point where this is. Get that out of there. And I've got the laser set up. We got this bearing out to this point, but I got the laser going essentially down the very tip it's essentially at the back of the beam. I mean, I could have moved right off the end of the joist, but I'm just showing up on most of the ends of all the joists. And you can see here, this one needs to be cut back at this point, as well as the rim needing to be cut back, and whatever weird, yeah, it's just a drywall return that they put a 2x4 on there so that they could catch the ceiling on that. That needs to be cut back. But so we'll need then, and you know, the 2x4s are 1.5 inches. The layers of the beam are 1 7/8 inches. So it won't be perfect, you know, 3 2x4s. But what I'm basically saying is you need one bearing post here, one there, and then a third one here. So right now you've got these existing 2 studs, and they're not quite exactly where you need something to be, and we need to, make a bit of room over here. So, what am I getting at? To start with, a pair doesn't fit in there tightly. It rattles around, and so I've also not going to go up and just land on the beam. I'm going to bring that pair of plates through there first again. So our new sticks are going to be this long. Our plate's going to have a repair, and then we'll have room for the beam. So I think to get started, I'm going to take this guy and this guy down and out of here. Really, they just return the drywall on either side of the short wall that was here. This is a layout stud, and that's a layout stud. So they're going to just get sliced off and go away. I also took away the drywall in such a way here to allow me to repair that plate, but I took it away so that we get our both sides of this new window all in the new sheet. So we'll have a full sheet across the bottom, and then what amounts to a cross-cut sheet across the top with a notch for the new window. We'll make all our drywall repairs in one, and I can get in here and work right now with, to the degree that I need to. You may have noticed there's some kind of hole through the sheathing where we're looking through the back of the siding. Unsure. It isn't a full profile for this beam, so there's and I wouldn't have imagined that they pushed the beam in through there. For whatever reason, there's just a big ragged hole there. So we'll probably go out and do a repair there when we put the rest of the fascia and drip edge on the eaves out here on a day that isn't 89 degrees out and 100% humidity or whatever it is. It's supposed to be down temperature tomorrow. So I'm just going to quickly translate all that lineage over there, trim all that down, take those sticks out, open this all up again, and then come back in with our bearing, come back in with our plate repair, and then we're down to cutting. There we go out here. And we're down to cutting with the circular saw at full depth along those studs, and then finishing the cut carefully so that we're not coming out through the drywall upstairs in his bedroom. And as we do that, we're going to hope to feel that we're not getting any pinches. The blade's not being pinched. We'll probably start the full cut through to the back of the drywall out here in the middle, because that's where you're going to have collateral sagging like this. Because you got bearing here from here over isn't really on our radar right now because it still has the original bearing. But from here to the outside wall, if this is going to settle, it's kind of on the outside wall, and on that bearing, it's going to settle in the middle, which is why I keep testing the shore. It's never moved so far. However, that plate for that wall and the subfloor cantilevers out into space off the end of the joist, but also the plate is over onto the edges of the joist by a little bit, and that may be affording us some strength here. So we're looking for pinching in the original cut, then we'll finish the cut in the middle and see if there's any pinching there. Then we'll sneak those pieces out of there and see that nothing's really moving, and we'll work our way out to the ends and just make sure everything's copacetic. In the event that everything's looking good still, then we can pull that plate off and cut the subfloor back flush with basically where that laser line is. And with this wall built with a bearing, I also turned the beam layers up downstairs. Don't ask me what I turned them up for, but we're gonna have to decide exactly where they go, and then we'll put the subfloor repair on them, and I'm going to screw through the subfloor here all the way out to the outside wall. They're in a bay, so we can't actually nail them together, but I'm thinking if I'll probably go through half a dozen times on the center line here and drill a hole in the next joist so that we can put one kind of long screw and apply it with a drill gun in the next bay and run maybe, like I say, 4 to 6 nice long timber lock or ledge lock kind of construction legs through it, just to make it all one piece. We still have got one joist under one jack under the beam, and then another joist under the other jack under this beam, and the same on the other side. So all in all, they're independently translating the load, but all together, married together, if that's easy enough to do, that would be really well worth doing that. So I'm going to get to work here now and try to complete all of that. And tomorrow's mostly just hauling all this debris and crap out of here safely. And then hopefully early next week, we'll put these beam layers in, and we'll be moving down that way. Tim put some plywood here for the sake of just keeping from splitting. There's small pieces. This is just a little bit of a scab to catch the edges of this little filler piece that he made. And so making them from plywood keeps us from putting it all up and the last screw just breaking it into toothpicks and having to take it all apart. Everything else worked out. We put a nail in everybody here. Ooh, and before we do this, I'm going to literally put those on the floor so that I'm sure once I have the horizontal 2x6 plate here that my 2x6 jacks are right on that exactly, just as a matter of best practice. And this line right here is 18 feet exactly to the back of the OSB over there. So we know that that's our beam length. This is the split between the 2 jacks under the long beam, 2 jacks under the short, and we know what to cut the beam now. And it's Thursday, we got Friday and all weekend. I don't want to just gut out everything structural here. There's 2 windows upstairs. There's a Jack King and Jack King there, Jack and King here. I did cut him off. I should back up. And we're not seeing everything squish, but those windows are heavy. There's some other things in this wall that, like, I don't need to break the drywall and have a crunchy drywall and have to be up on the carpeted master bedroom trying to make drywall repairs at the floor. It's just a place where a small oversight, because this crunched a little bit, could really create a lot of extra work here. So we're going to be as careful as possible. I'm going to spend some time and get this end ready for the beam today. And then we're going to hold off and leave everything supported like it is until next week. And we make our 18-foot pieces of beam. And this, it's got 3. I got this whole area cleared out in the wall where we can put our 3 2x4s in here, solid pack. And then that'll all be waiting for us. And then we'll go right along and open this up enough and then come right back in with a layer of beam and get right back underneath everybody right to start with and make me feel a lot better. Put a few joist hangers on it and go from there. So we're kind of done here until we get down to doing that, and we're going to put the floor back together. And I guess we're going to, we also drilled, I'll go look at that quick. We drilled a little bit of clearance because you can't nail these beams. Ideally, you would laminate these with nails or screws, these layers, but we don't have the ability to get a screwdriver gun into the side, and even the next bay has been split for whatever reason, and this one there's just several layers away before you can really get in there. So what we did here is we went to the largest of these additional spaces, immediately adjacent, and we drilled it with a Forstner bit. You can see the mess on the floor, but we've got like a 1-inch Forstner hole, and that will allow us to put a lag replacement screw either up and through there or get it started here, and then the screwdriver gun behind it and go in to some extent and probably put an extension on it. It'll be a little bit of fiddling around, but we'll get a nice long lag replacement screw through all 4 layers there and there and there. They're about at 16-inch intervals, and it will be huge for the overall strength of that beam. Far greater than the sum of its parts then when they're all attached to one another. And then we're good to go there. So it's just a hurry up and wait thing, but I think it's the safest bet. No reason to go for days with very little structural support. All you need, we're not going to get a snowstorm, but all you need is a lot of crazy wind or something else to just influence everything a little bit more than it was when you left it, and have, again, not catastrophic failure, but just a little crunchiness, and then you got a whole problem upstairs that we don't want to have, so we're just going to play it safe. And, okay, so over here, we plotted out exactly 18 feet from the end wall. There was a line, but I drilled right on the center line of it, just to see that our seam is where we want it to be, and it isn't quite perfect. So, in the interest of making it perfect, we're going to put this here. All right, push it over there, Tim. Go for it. This is an inch and a half, inch and a half, inch and a half, and inch and a half. And we're going to shove it over, and then we're going to nail it when we're there. Hang on, stop. Now just push consistently on it, no lurching. Push a little bit more. A little bit more. Hold it, stop right there. Hold it. There you go. So now we're, on both ends we're in really good shape. And we can snap a line here, yada, yada. We can also go down and look at those pieces of wood, and we can pull a string, probably just down one of the cracks, the middle crack or whatever, and see that he's straight. And I'll do that right now, and then we'll just nail this thing through here, and we'll just know that it's, the thing about something like this is you put it in there and you trust that it's perfect, and you work to it accidentally later in the process when you can't be sure that it is. And so we'll just make it perfect right now while we have a second, and then we can work to it, with reckless abandon and never worry or question it. Okay, so first thing Monday. Now, over the weekend, I was moving the 3D model around, and I was, honing in on if we're going to 216 from the center of the beam, or the center of this post, being at 18 foot, that we're talking about committing to. That's where we ended up in the floor and the site over the course of last week, and basically bringing things that we've decided on into the CAD space to be sure of stuff. And I really ended up feeling that post is a bit left. What is the deal with that? What's the deal with the post being over there? And as it relates to the wall that we deconstructed between these two spaces, I had imagined it more at the end of that. It's sort of in the middle of this here. It ends up being it's a bit tight here. If this is our general idea of proportions and stuff, it really needed to be kind of over there. What happened here? What's going on? Well, my discussions with the architect and his, reference being the original blueprints for this place, had us talking about, the biggest possible span was our goal, and to be flush here was our goal, and shouldn't we use steel, and all these different variables. And we ended up settling on the idea that we could roughly be in what we were calling the middle of this short wall as per the blueprints for this house. And so we get down to it here. We've taken the bearing away and the beam away on our left here. And on the right, this is the bearing and the beam, the shorter span that goes to the right. And this was kind of the middle of that short wall, and it worked out perfectly. That was where the cold air return was. That was the one uninterrupted bay between two joists on a 16-inch on-center layout. It was all coming together. And then we found out that this wall wasn't actually on the steel. I'm sorry, the steel's back here. We found out that this wall isn't on the steel the way it showed in the blueprint. It's actually over here. So then we started to say, well, we got to go over there with something heavy and have a heavy beam underneath the actual bearing for these beams in here. We need to do better than what the original builder did. And so we decided to put the 4 layers of 2x10 in, and we had said we'll be on the center line of this short wall, and we got those all in and everything just so. And again, I sit down and I look at the CAD, and it's a bit left. What's the problem? Well, there's a big difference between the blueprint for this house and the location of this short wall. And that ended up making us a bit left here, where we really need to be over here. This is where everything was supposed to be, and that's where, those are the two, I believe, 2x4s that return the drywall on either side of the temporary wall that was it, or the non-load bearing wall that we demolished out here. Or actually, no, maybe it was even further. It's over here, right at the edge of this flooring. So it kind of terminated into this bearing on here. And in the drawing, it shows that happening. In the original blueprint for the house, it shows more short wall. So that's where we ended up in a kind of a bad way here. So I pulled all the nails out of the top of those layers with the nail puller, which is a bit of ancient technology. We took the patch back out of there. We're going to unscrew the big lag replacement through the side, try to tip them over, slide them back out, and reassemble what we need kind of in this area here, which it turns out with our maximum allowable span, if I go to the drawing that we paid for the stamp on from the architect, and we see the maximum span, which is the free space over which the beam is going. So you can see the end of the measurement here of 18 foot 9 inches stops at the inside face of the wall, stops at the inside face of that post, is an 18 foot 9 inch span. So if we add 3 inches of bearing, we're at 18 foot 15 inches of total beam length, and we were about to cut that thing at 18 feet even. So we're adding over a foot of span as a factor of just figuring how much more beam we're going to cut ourselves. And I'm so glad we didn't cut that 18 feet, just feeling excited, last week, or we'd have been married to this situation and working around it forevermore. So that actually means that this longer span is going to be on jacks that are in the location of the jacks that are currently under this shorter span. So that is a problem because we've got to demo this all out of our way, and we've got to be at least to here with our new beam and have our new jacks that are taller, see, because our beam's going to go up flush with that floor upstairs, and they're going to be made of 2x6, so all of this needs to be out of our way. We need to cut this beam back then to do this operation over here, and so we need to put some kind of temporary bearing, you know, to replace this, so that'll be where the other shore comes in. I can put a plate of LVL or 2x10 or something on the floor here to disperse between two joists, which is ideal. Run the other shore up underneath this thing here. Then we'll cut him short. I would like to see a little more temp wall underneath, you know, over there and over here, so we'll get that built into place. And then we'll be down to putting our bearing up and putting our new big beam in place, and it'll have that post scooted over to where it makes more sense in our general plans for the kitchen layout. Because in the end, this over here is a bit of a walk lane and less of a room. They may put a dinette in here or something like they had before a little bit, but I think that taking some of this is going to yield a way more functional kitchen, which is really the focus here. So like I said, I got the nails out to this point. Tim's getting us some room downstairs, and that means I am going to go out and I'm going to put the eaves together. I'm going to put the soffit up, the fascia up, and then see what to do about the drip edge. Now the drip edge only comes in 10-foot sticks. The fascia comes in 12s, and the what's the other thing that I bought? Something else. I guess J-channel comes in 12s, but drip edge is only in 10-inch or 10-foot pieces. So I got 2 of them. We're going to need 2 of them. That has a hole in it, like I was saying. I'll probably start by getting up and trying to cut those fasteners and get that old drip edge out, and then put the fascia, which has a shelf, and get that to come up snug against the existing soffit, and then try to sneak the drip edge in above that. And I guess the last thing will be to put the last little pieces of soffit up. We've saved some vinyl soffit from the other, you know, the edge out here that was on the chimney. We'll put that soffit back in place, and it should work out. And if it doesn't, we can rip one piece of it to fit and work out. But I'll probably try to button this all up while Tim makes ready in the basement to switch the location of those 2x10s, and then we'll be back on the right track. Now it's a point at the project where everybody's so excited to just get that beam in and keep moving forward, but I'm just glad I caught that little discrepancy in the nick of time, and we won't spend a couple of hours making, you know, changes, and then we'll have a little more work to do. But that work would have been, now that portion of what we're doing here would have been necessary from the get-go. We would have decided that we needed more support wall. We would have seen that we needed to cut that beam back. None of that is really rework. It's just additional to what we had hoped to have to do before putting the new beam in. So that's not really doing anything. Really, it's just moving those 2x10s over, which will be a couple of hours, and then we'll be back on track, and that's all the more we'll lose in terms of efficiency on this project. And in the scheme of things, that's still a really small little bit of rework, where we could have had all kinds of problems so far that we haven't had, knock on wood, and so I'll take it. And that'll be something that we stop to do that we'll pat ourselves on the back for probably the rest of the duration of the project, having that extra foot or more of span and room around the kitchen island, and I'll continue to point out where that comes into play and why we're so glad that we did it. So you want to keep eyes out, you know, for situations like that. Meanwhile, I'm going to take advantage of a mid-70s degree day and try to do some outside work. Okay, notice a professional sided this house, at least to some degree, or trimmed it anyway. Notice your fascia on the eave is tucked into the fascia on the end. And then, let me see if I can show this here. That's horizontal. And then you got the fascia that comes down at an angle. That's the last layer. And so everything is sort of shedding water correctly, and it's not, the ends aren't feeding water in and behind the fascia on the eave, and that's what we'll copy over here when we get here, meaning that this end of this fascia won't have any end treatment. It'll just slide in behind and then be face nailed adjacent to those holes that are in there already. But then we'll have the anatomy correct here, and the bottom edge of it will sit up and above and onto the ledger from the end that wraps underneath there, if that makes sense. So we basically haven't got to put any unique features on the end of this when it goes up. It can just go up. However, I do need to see, I do want to be sort of either in front of or behind that fascia. And so we have to make sure that we've got a long enough piece, which I'm pretty sure we do, but we also need that gutter up enough to allow us to either, I got to pull some gutter hardware out of there. I probably want to do that. I probably leave this all down and apply it as it is and send the new fascia around or underneath behind this gutter, but on the top of that fascia, instead of trying to slide it in behind there. I don't think there's any benefit to that. So just apply to, we'll leave that fully as long as it is and go that far. So I got to get a measurement on the fascia piece, get a measurement of where that puts our end down here, and then sit that gutter away and take all the hardware out that would be on our way to that point so we can do that maneuver. And then we'll go up and we'll put that up with trim nails, which are aluminum, white, 1.25 inch aluminum. I said that already, but because they're aluminum, they're kind of stout. They seem a bit thick, so they've got that kind of strength, and that's what they're for. But first we got to get that right, so when we go up with that piece in this little bit of a breeze that we've got, it can go right in place and it isn't blowing around, getting kinked or bent, and we can put a few nails in it and then move down and put a few more before it gets, like I say, blown all around. So we want to be wise about that so that we're ready. And once it's in place, we can look at sliding some drip edge back in. I don't think I can nail it, although I might be able to. I'll have to see. I'll at least put a bead of sealant across the back like that and try to just push it in and let it glue itself down, and that hopefully be enough. I'd rather that than really bend the shingles back enough to nail and start compromising the shingle or anything else. I don't think that the drip edge is going to blow out of there if it's stuck down with a bead of roof sealer, which is that polyurethane stuff. We'll just see. Another thing I want to mention quickly is it's always nice when the customer has something like an extension ladder or something like that I haven't got to bring my own to the job site, and especially if it's safe enough, and this is generally no problem in that area, but it's back assward, and I don't know, that's probably what happened. Maybe I'm wrong to color, but you see the flat surface of your rung, the ladder has to tip this way for the flat surface to be the appropriate surface, for walking. To tip the ladder the other way, it wouldn't be in the right orientation. So this is the way in which it's supposed to be used, except the frame on your side of it has got the feet, and it's the wider frame. Nowadays, it's got the feet, the wider frame, and then the narrower frame is on your side of that, and that's the one that goes up and down. Whether you use the string or not, it's the one that freewheels up and down because it's facing the operator. This one, the frame that slides up and down is the narrower frame, but it's on the back side, and so you really can only use this rope to do it. And I had to wax these rails all up, but it still doesn't want to slide very well. And so it's altogether a wildly unhandy extension ladder to use, just for being before we standardize the way that they're constructed. But it's more trouble than it's actually worth in a lot of cases here. You want the narrower frame on the operator side, and you want it to move up and down thereby, really easily. And there's basically nothing that can be done with this. It'll always be on the wrong side from the person, and always a gut buster to try to get it to slide or to yank on this enough. And if we get off the pulley like we are up there now, then we can play games with that. And it just, now, why won't you just go onto the pulley? If I get you to come off the pulley, then just go up and around and stay onto the pulley. And then you can't even pull it. Oh, and then the two frames are the exact same length. So when your two rungs are set, this comes down to stop, and then the surface of both rungs is a nice comfortable stair to stand on. At this shortest level, you can't put anything on the ends to protect the house, like those little rubber things on the feet, because the frames are exactly the same length. The one frame isn't, just a little bit longer to allow you to do that. So while the overall ladder is just short enough to get in where I need to get in here, I've got to monkey up the siding with the raw ends of the aluminum, because it isn't just a little bit longer to be able to put anything like that on, which is just, and it's just raw aluminum rather than there being a plastic kind of bumper end. There's just the little details here. You want to watch out for what you're getting for a ladder, because this whole thing is just sort of more trouble than it's worth. No offense to anybody other than Keller. I don't know what they were thinking of, but I think that's why they're probably no longer around, or at least they probably got their act together, and this isn't the type of ladder that they sell anymore. I don't know, maybe I'm wrong. I guess we could talk layout updates now. I mean, just the other day we repositioned this new construction. Yeah, welcome to the Matrix. 3-ply, 2x10 Hemfer beam. It was here because, again, we had a discrepancy between the original blueprint and the new, and ultimately we should maximize its location to the right, and so we scoot those 4 layers over here, and that's where we end up putting our post, as well as finding out that the existing steel, which runs into this notch in the foundation as it sort of logically should, is 8 inches actually difference. In fact, this is supposed to be 100 inches from the face of this foundation here to the face of the foundation here, and that's where somebody made an error. It's 108 inches, and I'm able to see that by measuring concrete face to concrete face outside. And so because someone made this too deep, the steel went into the notch the way that it should have in the foundation. They kept everything else the same. And then when they got to the second floor, they took the opportunity to come out here and cantilever out so that their second floor layout remained exactly, the way the drawing called for, and their rafter geometry all, was the same. It didn't change the roof angle. You can do a lot of problems from the ground up if you can't make a change like that. So luckily this occurred in this little, sort of, hidden place on the house. You could handle it. So somebody got right off this, bat and made an error in the foundation, and it chased them all the way to the second floor. So now that 4-layer beam was necessary because our post can't land on our steel. And so I've accounted for all of that in the drawing space. Excuse me. So we've also placed the sink on the center line of the window, and we've got the dishwasher to the right-hand side. We've got the garbage on the left-hand side. So you got to clear the plates, rinse, into the dishwasher, no dripping all over the rest of the kitchen area for the most part. Conventional 24-inch width lower cabinets, and the 16 is for this little peanut lower cabinet that you open and then the little guts of it sort of pull out so you can get to it. It's one of the ways in which you can solve the problem of an inside corner cabinet. So in fact, it's blind. The box itself goes along like that for 16 inches on this face. It's 24 inches deep, and the little, again, jelly bean shaped platter or whatever goes over into the cupboard there. Then there's a little 8.5-inch wide sliver cabinet here to put this 24-inch base on the same center as the window, which oftentimes looks nice. Another 24-inch base, and then for right now we got the gas range here. This is the existing 26x30 gas range that we're going to put in, and then there's a bit left over between here and the window. Now I think 18 may be a little tight because this is the window equipment only, no trims, and so we may have to go down to 16 or even maybe 14 here with the lower upper. For a coffee / not a wet bar, but an alcohol bar. You could have a glass-faced cabinet on the top for all the alcohol and coffee stuff in the bottom, or just the Keurig or something on top, whatever the drip pot. We're going to have a pot filler. If this is where the stove goes, the range, there'll be a pot filler, and so you'll be able to fill the Keurig at the pot filler too, which would be kind of handy instead of going all the way to the sink here. And then we talked about in the lower, maybe half the lower is a tall, thin drawer, and so baking sheets can go in edgeways, again, next to the stove in this position. Now, I keep talking about the stove in this position because there's a chance where, we take the fridge and put it there, and take the stove and put it there, because I've got the baker's bench set up here. Because Holly likes to do baking, is quite good at it, and I think it merits a separate baker's bench area. I gave her a baker's garbage here too, so that could, and the orientation of some of this stuff is for consideration, because if you want to pull it open and leave it, so you do a bunch of stuff where you're constantly throwing stuff in the trash, maybe it isn't handy to pull it towards either the oven or the refrigerator kind of personal space. So maybe it needs to pull right, left, or out the back or whatever like that, and who knows whatever else there. Again, if we put the oven here, then it's real easy in and out to a baker's bench and back again with cookie sheets and whatever else. But again, there's no problem probably with doing all of your prep. You want to think about your surfaces as two different places. You got storing or staging, and you've got the work of things. So if you are doing Christmas cookies and you're doing all of the rolling and shaping and putting it on the cookie sheets, but maybe you're staging the sheets on their way to this oven, now that makes sense to take this right along in that direction. So a lot of things to think about here. Coming to the island as a result of that, I put the microwave in this corner so that opening and closing the door isn't in the personal space of someone at the sink or at the stove/fridge here, and it isn't in a narrower walk lane, because we're down to 42 here after you put drywall on there, where we got 44 here. And so, you know, maybe, and again, you get something from the fridge, or you get something from the fridge, you toss the, you know, extra packaging in the garbage and you pop it in the microwave, you know. So trying to keep some of these things, you know, sort of logically. Then you've got regular conventional 24 with cupboard, you know, doors that open this way. This one goes in, it's a little shallower, but I had it pointed toward the baker area. So again, where you go with the access to this lower cupboard and the baker's area, you could have all the stuff necessary for baking in a cupboard that faces you from an adjacent surface, and in a cupboard that's underneath the actual surface that you're working on, maybe even in the cupboard over here. It depends. And if this turns into the stove, then maybe we need to massage this area a little bit and end up with that. I really like that thin pull-out baking sheet. But if the stove's over here, the range, it doesn't necessarily need to be left right of there. It could be one of these things, you know, it could be on board the baker's bench. So variety of, you know, discussions to be had here. And then the other thing I was thinking is, you know, you got 1, 2, 3, 4 conventionally wide or widthed lower cabinets underneath this outer face of the island for your seasonal or your infrequently used items. And we may pull the top surface of this island off so you could sit 1, 2, 3, 4 people, 1, 2, 3, 4 chairs in a breakfast bar situation or whatever up at this edge of it. Because again, you got formal dining adjacent, maybe breakfast with the kids and whatever else happens on this edge, but at least you've got 4 equal doors if you take this route, for 4 equal chairs, and, you know, a variety of, you know, opportunities there for visually, you know, for visual correctness, or all that you can do to handle that. However, you can also, you know, maybe this is a situation. I was going to say one of these could be a drink fridge. Sometimes it's nice to have a glass front wine and beverages refrigerator separate from the regular refrigerator, especially when people cook and bake. The fridge is often tied up with, you know, more raw materials, and you don't want to trip through dozens and dozens for a full family of 4 of beverages, bottles and cans. So that might be nice, plus wine, which is always awkward in the refrigerator. So maybe this turns into a drink fridge, or maybe something over here is a drink fridge. A variety of options there. Again, we're going to hammer some details out and then work down to what we are left with. There's no real opportunity for an upper cabinet here, even if you do a fridge instead. And even here, it could be an upper cabinet. It would be a little narrower, but we had talked about liking the look of some open shelving, not too much. So maybe some open shelves here, and then an adjacent here that kind of complements, instead of one weird outcropping, 2 sort of complementary outcroppings of open shelving. Altogether, kind of starting to hone in on things here, and I'm getting really excited about it. I think a lot of this is making sense, and it's just a matter of everything finding its place, and from here, you know, we just continue to refine. But that's a general idea where we're at right now. Well, we're back, and we're going to handle this situation by extending our support wall over here and erecting a temporary shore pair with a 3-layer 2x8 beam due to elevations, restrictions. These only get so short. We're going to put those up on some plywood to spread the load out, and then we'll have that much more temporary wall and support on either side here, and thereby we will be able to cut this LVL back, and we're going to add some attachment that we were fighting over here too, so that when we take this physical bearing out, it's the weight of the LVL doesn't just come down sliding off from nails over a period of a day or 2 over this weekend. So we'll put some screws up to hold that weight up. The bearing on this, under this, will be the shores. The bearing under this will be the temp wall that Tim and his wife extended. And then we'll have everything out of our way so we can put the plate and the jacks and go up into this end wall where he cleared out some more space for us. I just got to fix up our plates there, our top plates, and he got some mend plates over the hole in the sheathing, which is, you know, you could get just any galvanized steel. Those are already perforated mend plates. We'll make sure that they're nailed into the end of the beam, and then we'll zip tape all those over so you won't see any light through there, and that'll fix up the hole in the sheathing that shouldn't be. And then we'll have this beam in, and we'll start working on that. But that'll be next week.
Booger. Booger. Booger, booger, booger. Booger. Booger.
All right, Tim is finishing up the last couple long studs from the upstairs wall. Everything else is cut clear and out of our way. The end of the house is all probably a little overly opened up, which will make hopefully that, fitting that up in there easier. We don't want to be trying to wrestle that big layer of LVL up and being too tight. We left the shore under this setup here, so it's pretty much locked in, even though we don't expect to see any movement there. And the fact is, now that we're here with this 4-layer beam, from over there we came to here, our pair of jacks, I don't know if I said this already, but our pair of jacks for our new beam is almost exactly the jacks under this end of this other beam, the existing beam here. So all of that has to go out of our way. And, I couldn't get underneath that LVL with my shores. They don't go short enough. So we just put a pair of 2x4s under it for right now. I had thought about taking it right down because what we did was we put this temp beam up on this side, right? Put 3 layers of 2x8 and a layer of plywood. That left us a little bit. We could have used LVL, but I didn't bother with that. There's already 3/4 inch, hardwood on this floor. And so we're underneath these the way that we're under there with the temporary wall. But I was loath to go buying any more 2x4. We're going to try and use this all up when we're done here on this project, and we don't need any more if we can help it. And the thing about beams are your customer's going to buy those, and then we don't really have a use for 2x8. So we do have a use for 2x4, so we went temp wall, even though I could have put a few of these in here. I have 4 shore and several weeks ago. So now that that's all locked in, the reason we're not taking that down and we're just cutting it short is because we can basically stay under everything now with a pair of jacks, and that's better than trying to pull this down and having this entire thing sort of half on that. And then we haven't really extended this temp wall. I really wanted to do this in 2 big bites, and so we're gonna do it in 2 big bites. It just took some fiddling around because we ended up needing to be right where the end of this existing beam was with our new one. And so we're forcing the issue. We're just gonna cut him a little short, make ourselves some room, put this other beam up on the right, and then we'll be ready to execute the same thing on the left using this old beam. And we're just, like I say, playing it a little bit safe. I'm about to cut that off, but we're moving the bearing from there to there now. And so there really should be no issues. And that's the end of our bathroom wall between the master bedroom and the bathroom upstairs. And so that's in here also, and it should be under a rafter. And so in that, or it should at least have blocking between 2 rafters to tie the top plate of that wall in. So all of those fasteners, etc., are going to bear this short wall for us in this region. And so I'd like to say that we could trust that much out of this contractor. So let's go ahead and cut this free, and then we're going to make ourselves some jacks, and then we're going to put our layers of the new beam in. And it'll really just be, how to get them in this door through this wall. We'll probably have to remove some studs, and then Tim and I ourselves how to put 1 layer up and control it enough, and then put some joist hangers on it. And at that point, we'll be really good to go. All right, we're gonna get a bite of lunch here, but we're completely on this temp wall, this temp beam, And the weight of that LVL and peripheral sort of loads are on this pair of temp jacks. I got a plate analog on the floor, and I went up to 18 inches down from our fresh end on those and put that line. And we got a 95.5-inch sort of length, so that'll be our jack. Everything's gonna be made of 2x6 here because we got to get under 3 layers of their new beam. So we'll make just the one 95.5 jack. Then we'll make sure that we're at exactly 18 and cut our LVL first layer. Oh, we got to take the rest of this out of here, you know, so we'll hand loosen that, make sure nothing's dipping, which I don't think it will be. Knock on wood, but it shouldn't be. And then we'll put one layer up. On this end, it'll stay. I think I might like, before we get down here, to do the same like we did there with a little ratchet strap sling, even if it hangs open until we get the end in place, and then we get the hook end and we go up to our, you know, big, we use a lag replacement screw there, and then we can set it in the sling and just sort of reconnoiter. Don't want to stand here and, you know, try to wrestle it and not have another option for where to set it down. It'd be nice to put a rigid like 2x4 across here and screw it in. You know, we could always do that if we felt it was going to be necessary. Maybe we could, I guess. If we get a one screw through one here, we can just swing it up and screw through it. Maybe that's a better option. In fact, we could even set it up to sort of hold it at the perfect, practically, you know, just a 1/2 inch or 1/4 inch lower than. That's what we'll do then, I guess, because it'll hold it just about where we want to be. And then using the jack, we'll pick it up off just a bit as we snug it. And then I'm going to go and look and see what kind of engagement we've got with the ends of all the upstairs wall studs. You know, and, you know, that we got how many chances here? We got a dozen or more chances here to be a little proud with one of them. And the thing is, when we let all these temp balls and stuff out, if there's only one or two touching and all the other loads, you know, coalesce or sit down together, you could have tear out in those lines of drywall screws upstairs as those dip a little bit lower or something like that. So once we get that first layer in there, we want to see if, you know, we have any trimming to do, whatever, and we'll do that, which isn't often the case in any other circumstances for me, but I'm normally not trying to do this behind a finished upstairs wall. It's normally just in the plane of a floor. Now this beam height that we're installing is so high that we're going to put ourselves up into the wall upstairs, which is a nice place to put yourself. Thankfully, it's an exterior wall, and the one side of this new 3-layer beam is in the interior of this house, because it's got to be thicker than the actual wall framing is. And so if we were trying to push a beam like this up into the upstairs wall and it was finished both sides, one bedroom, the other bedroom, whatever, obviously it's wider than the 2x4 wall is, and then you end up with an issue there. So then we would have been back to 2 layers of LVL, maybe go to 24-inch layers, maybe end up with a fletch plate in the middle of it of steel. Still, that's a 3/8 thickness, and it just is it's gonna push you out wider. Yeah, much wider, even in the 2 layers of LVL. So we're really lucky here, basically, all things considered. And I just can't wait to get that in place. But I got some phone calls to make, and I got some lunch to eat, and then we'll do
slight angle on it.
Just recut it. It's all good.
I'm gonna come from the other way.
Yep. In this case, you can just keep the notch on the line.
Okay.
You don't have to necessarily watch the cut. Yep, look right down, just keep the notch on the line. Recut. Just recut it.
Why is that binding up?
Because you're trying to turn. There you go, baby. There it is.
Right there.
Yes, sir. Okay, so that was relatively painless. We have got a safety screw in, a couple safety screws down there, but turning up here is just scrubbing into that. So we're gonna take another couple inches off just to be sure. I was just telling Tim I hate to cut this thing any shorter than necessary, but in the scheme of things, we need it out of our way to go all the way up. So we'll cut that back, then we'll rotate this up and put our jack under it, under our floor plate. And then after that, we should have an easier time. We'll have the room that we need with the next layer. We'll have our methods down and everything will go so much more smoothly. Okay, we threw the laser on the bottom of the beam, or the first layer of the beam. I went to the middle of both ends, and we had a bit of an arc in the center. So we dialed that. We took a little more. A couple of these joists were a little high. Took a hair's breadth off the back of them with the vibrating saw. We used the lag replacement screws to pull deeply into the end grain because there's like 6 inches long to give us a meaningful amount of power and thread attachment to pull that bow down straight. And now I'm seeing the laser. It's not perfect, but boy, is it really close to going down the center line of that beam. Close enough so that the outside drywall corner, when we get on the out, if that next layer and the layer after that, and then the outside drywall corner goes through here, we'll be able to get that straight. And when we're all done, when you look down it, it won't have a weird bend in it because it'll be otherwise structurally sound and everything else and well finished. But we just want to see it nice and straight from one end of the house to the other too. So we're just watching what we can do with the framing. Then we'll put up the next layer and nail it on, and then the last layer and nail that on. And we'll shoot 9 fasteners every 16 inches. And so since we've got screws going into these end grain of these joists right now, so that the shear strength holds this layer up, because we got to come out from underneath it with the shore and every other structural thing here and go up in with 2 more layers. It's got to stay up until all 3 layers are in, then we can put the jacks under them. So since it's got to stay up, we'll have to put fasteners into the end grain for their shear strength, and then we'll nail the next layer on and carefully remove the support from it to make sure that that added weight isn't too much for that shear strength, which it shouldn't be. Then the 3rd layer, same thing again. Then we can put our jacks underneath everybody before we leave today, and we'll be in really nice shape. But because the screws right now are going into the joist layout, then the 2nd layer, I'll probably go in the left 3rd of the bays and go 9 fasteners, 9 fasteners, 9 fasteners. And then the last layer, I'll go to the right 3rd of every bay, 9 fasteners, 9 fasteners, 9 fasteners. So we won't be accidentally shooting into the heads of screws or other nails with our nail layout, but we'll end up having 9 fasteners every 16 inches for the length of these in, the first 2 layers and the second 2 layers. And thereby we'll have a nice big lamination in there. And then, like I say, we'll get it up on a pair of jacks so there's a physical bearing, and then we'll get out of here for today. Well, like my buddy Robin from my old Fisher Price model shop days would say, that's the kind of beam you read about in Beam magazine. Meaning, it's a real centerfold situation we got going here. I'm pretty happy with this. Tim had to bug out, and I'm just trying to get a jack under it for now. That's the one we decided mathematically we wanted to try and make fit. And so I've actually manipulated each of these layers up and down while supporting them with the shore, but overdriving it down or up to get the layer flush as possible right along as I commit. Now the first layer I did with nails because it behaved itself pretty good. The second one was having some problems becoming flush without being, screwed together, and then do some more bending and then screw it, and then a little bit more up and down over here to get everything. Now it's really good. I put it together once again with these big ledger lock headed screws because they're going to end up working like a clamp. And see, that's all the deeper I could grab with the clamp. But I put those screws in at about the halfway point, so I'm pulling kind of everybody up equally. The one thing that I want to do over here is, I think, despite the fact that all three layers are pretty faithfully and flat and flush, assembled, there's a gap up there, and we're just, it's a little optical illusion and a little bit of reality, but we're sitting to the right a little bit. And so I'm going to end up getting like a 10-inch Fasten Master construction screw. And I'm going to go through all three layers, and I'm going to reach for some other like inside corner wall framing and try to pull the whole, all three of those left a little bit tomorrow. But tonight I can get the jack in, and then Tim can pull some temporary walls down tomorrow once there's a jack underneath this beam. So like I say, I'm just going to go up with everybody now and see if I can hand tighten that enough to get the jack in there. I'm going to compare the beam to subfloor distance there with the beam to subfloor distance down here and maybe in the middle and find a happy medium. Maybe I got to cut that thing, maybe I don't. And then I'm going to call it a day. Okay, I got the jacks in, and I was able to lift. I was going up with the two shores and ended up being able to add that third one out back. I forgot all to get this up to approximately the same elevation from the subfloor as that end. And thereby we've got a little bit of a heavy 1/2 inch sag in this, just collaterally on account of that whole system having sagged on the old beam. And then this temp wall was built in, measuring and adding every stick because you can't rightly lift it at that time. And so those hold it in that sort of low position, and then that's where you end up. So again, I've overdriven this so the two ends are where they should be, and there's a chance that we could set up the shores tomorrow and lift as much as possible with two shores here in the middle, and then try to laminate at that point and try to keep that like preload in it a little bit. It has the two first layers have been nailed, and there's dozens of nails in there holding it in that position, so you're fighting the shear strength there. So there's really a low chance of being able to do much with the shores, and you're pushing it out of flush with the joists right now, and then you're trying to lift each and every joist to get there with the joist hanger and apply it. It's possible. We have the equipment here, and when you're lifting a joist, you're on the first floor joist when you're under the second floor joist. So there's a lot of things, to our benefit here. We will have to just see. Another thing that I must mention is there are two windows in this outside wall, and in this wall that is at 90 degrees between the master bedroom and the bathroom, there's an interior door. And just fixing this, lifting this area, because if you think about it, this whole span, the full length of the house was settling. So this isn't even the low point in the middle of this span. It'll be lowest practically at the bearing. But what was I saying? Oh, lifting so much in that area has that interior bathroom door out of square, and that will need to be rehung. So, so again, the windows were getting a little scrubby. So if we actually fought to get that as much, if we did any more lifting in the middle here and tried to get it all level, you'd have problems with the way the windows are hung in the exterior wall of the house. Then you can go up there and monkey around with that to try and make them work better. And so to some degree here, you won't see that 1/2 inch over this span, and it shouldn't affect us in almost any way. So, we'll get to a point where we probably just call it quits at some point. But anyway, that's what we got done today. On to tomorrow. We'll put those joist hangers in and then probably break a bunch of these temp walls. I'm just gonna catch us up, but we got all this Tim got all these temp walls down, and we put all of our joist hangers on, and we had a little squareness problem in the middle here upstairs between the bedroom and the bathroom with a door jamb, which I thought was gonna be something we had to fix with the jamb when the time came, but there was one low joist here or there that wasn't planing out with the bottom of our new beam. So Tim pushed up on it with a shore and put the hanger on so that they're flush. And he said immediately the door went back to working upstairs. So super bonus. And we're getting down now to where this layer is going to come off of this beam. There's enough engagement in the wall here that we chose to take what they had in here for a column out. Lo and behold, the electricity to this outlet was routed through it. So we had to get into the drywall cut back, get into the outlet, disconnect, chase the electricity up and out of our way. We'll get the beam down. We'll come back with what we need for a column. We'll put our new layers up onto that column and onto its new jacks. We'll come back through it. We'll pre-drill it before we put that in. So we'll come back through our holes that we gave to ourselves. And we'll come back and put our outlet back together again, and we'll plug in the battery charger. We'll go back to having what we need for power, and we'll be on our new, and only need 2 layers here due to the fact that it's such a short span. And the beam that came out of the long span, like we probably said already, will just get cut. Those are our 2 new layers, and they stayed in the house. And we'll put them right back up again. And then these here will go on down the road with me. I'll trade them back their material budget, a fair amount, and we'll find something to do with those at a later date. But for now, we're gonna move this old beam down so Tim can get ready and take the old rim and sole plate to the bathroom wall off. And then we'll be ready to put our new layers up. So anyway, other than that, I got outside and put the drip edge. I did the 12-foot fascia section, didn't quite make it to this side of where they stopped for that chimney bump out. It was a matter of a couple of inches, 4 or 6 inches or something, annoying. So then I put a 4-foot long sort of bandage new fascia piece from the new fascia to the old, snuck it behind the gutter, which will be taken down at the end of this week, and a whole 1-piece gutter with downspouts put back up for us. And so that's the impetus here, is I want to be ready for that. And then I put the big drip back up, and that's only in 10-foot sections. So I chose to go well on, probably to about there with the drip over the old drip, where it stopped at the same point as the old fascia. And then we kept going to a point there, and then I came back from the outside corner with an easy piece to install. Now that went up with 2 beads of that PL roofing sealant on it. I did dig all the roofing nails out of the old drip edge, this stuff. And that you can pick up the shingle enough to pull those out, especially if you cut them off with the oscillating tool. You can pull them up and turn them out of there. But you don't have the room to stand a new nail up and to nail that drip edge back down the way it's traditionally put down with nails, because that happens before you roll your ice and water in, before you put your shingles down. So our surgical repair is to put 2 nice big juicy turds of that sealant on the top flange portion, slide in and let the weight of the shingles and the heat of the sun stick it down in there. Then our gutter, a new gutter, will go up. The tail of it goes up underneath the drip, and then the new gutter nail goes right along underneath the drip edge. You should never pierce your drip edge. It should be kicking out and sort of hanging fancy free there. And furthermore, the ice and water wraps down and is in some cases, like right there, just sticking a little below that drip edge. Usually it's cut flush, but I left it right now because I don't need to do more. I'm not going to take more things away. It's worked in this overly long fashion here so far, so I left it right where it was. And once the new gutter is up, you won't see any of this. What you will see is the fact that my fascia repair doesn't have the same body line that the old fascia has, but you know, at the end of the day, and the 2 different suppliers, the 2 different fascia pieces. From the first time I thought I had what I needed for length, and then the second place that I went, they have 2 different products, so their body lines don't line up. Annoying. Actually, that one would have been far closer to the old one, but still wouldn't have lined up. So we got 3 different fascia profiles here, 2 different suppliers, contemporary, one from 30 years ago, and this is the way the cookie crumbles here, because we could do all of this just to make that work. But the thing is, the gutter guy, he only pulls old gutters down and puts new ones up. He can tell you if you're going to want to do work between the 2 operations. He'll come back and put the gutters up when you're happy. I want him to come and just be done with putting the gutters up when he's here, and that's it. So otherwise, I would say just pull these down for us and then let me do all new fascia that matches the same stuff, a whole new drip edge. No, again, scope creep, not necessary. So this is what we did here. And then when we're content, we'll put the soffit back in. Probably wait until he's done with the gutter. That way I can kind of see where his nails, I'm sure they do excellent work, but the nail layout should be on the rafter layout, and this way he could even see what that is. Maybe he'll find it to be a help if he didn't have a secret. I'm sure he knows how to find studs or rafters in a soffit. But anyway, then when we're all done and I can see his work from the other side in this area, I'll put that together with the soffit that we saved, and we'll be back and 100% outside and back to just inside with room to expand our bubble over. And Tim will be working on making his cupboards, which we'll look at that design progression after this. And then once we can put them down, the lowers, even if they don't have doors or drawers, and we can put counter instead of sink. And meanwhile, I've been plumbing while he's been building them. Then they can take their kitchen operations and bring them in here, and we could tear this old kitchen out. So that's our long-term goal. But I'm leaving them their kitchen right now to use until we're ready to provide them with a different place. So we're off and running now. Can't wait to see this over here to this level. This is really where everything should have been from the get-go here. So it's getting to be quite exciting. I'm just gonna mention this right here, but the last place where this little discrepancy is gonna get us is in the fact that one of the layers of this double rim goes right out to there, and so I've got to now cut it off flush with the back of the siding. So I'm going to push the oscillating tool up into the notch as far as it'll go, break it off with the grain, cut further, break it off, cut further, break it off. But you can still see here the gappage, the daylight, and obviously where the rest of this layer on the right is missing, that's all wasp nest. Because to start with, all the little finishes and ends and beginnings and corners in that little finished overhang are half a dozen or a dozen places for the wasp to have his choice to sneak in and build a nest, which is, of course, it's what he's done. So we're going to do everything we can here, as well as fill that with pest foam before we go in with our beam. And I wanted to mention that this is like, you don't see this until, the wasp guy isn't going to do anything for you here. You're going to have to do a project like this to discover why you have wasp problems all the time. So that started getting to a point inside where I realized what the situation probably was out here. So lo and behold, now I had known this is probably a place where, see all of this stuff? It's a little opportunity to make a hot route for Mr. Wasp in and out of the house. And so I had filled this with pest control foam. So I left that piece of soffit, but you can see that this entire space of, 6 by 10 by 20 was a solid pack wasp nest. And now we're gonna clean that out. And then, now that got twisted down because of when I pulled this soffit stuff back out of here. Our beam's gonna go in tight. And then once the beam is all in, I'll probably come in from this side and pest block foam that all up in that aspect. And then put this back together. And, this is the type of fitment that we want. That's a good assembly there. This is like where they were going in the top. And they'll just have to be careful here to see that nobody's moving back in, I guess. Well, the cool thing about a dust collector over shop vac is that it's gonna, and it's not like you can't put a HEPA bag in a shop vac, but that's essentially what it's doing. And it's also jostling the bag all the time, so it's not getting clogged with dust particles. So that is, a gallon, 2 gallons of beehive wasp nest that came out of there, wasp nest. And so at this point I can say that really what should have happened there was it should have been insulated, because it didn't have any insulation. And then there should have been a piece of 1.5-inch dimensional lumber cut to fit and cap the bottom of that opening and nailed in on the edges carefully. And maybe even construction adhesive or something like that. And then it could have been finished like this, and it would have been essentially impenetrable. Or the path of least resistance would have been, the bees or the wasps would have crawled into a point and realized it's really a lot of work to tunnel inside here. Better go somewhere else. It's that they found a void so easily that, and they were encouraged to be up and underneath because it's out of the rain in their little pea brains. In their estimation, so it's attractive. And so sealing it up with wood would have been a better option. At this point is quite a bit of fiddle work to do there, because all those custom little pieces of J-channel are all behind the clapboard and everything else. But if I wanted to spend, some time, that could be done. So for now, I'm going to leave it open like that, and we'll see what Tim wants to do about it. He may want to tackle it himself, but it needs to be basically capped, insulated and capped, and then put back together with what looks like soffit. And then it's way better off. And then you're down to however many other little areas where somebody behaved that way when building that are promoting the wasps to move right in. Just like that giant nest we found over here in that chimney bump out. He's got wasps over there, which lead me to believe that they're all along under the soffit of the garage, if not right into the rafter bay somewhere in the garage. Who knows? And he's right in my face right here. What's your problem, bud? They're doing something with this hydrangea. But That one was in my face. I don't know, can they smell the torn apart nest? Nobody was living in there, thankfully. But I don't know if they get a whiff of nest and it makes them feel like someone's attacking home, if that's what they do. Anyway, that's that problem solved for now. Back to work inside. All right, Tim's got this all packed out, extended the plate. We made sure we got room there for the ends of these layers. We have got like the sheathing from that wall coming at us. So we'll put the first layer in, and then I told them we'll put some pest foam in here and then squish the end of the second layer of LVL into it, just to do our best to seal up this gappage here that would otherwise maybe be around the corner situation. Then we'll go outside and I'll work to the end of the new beam to do foam, and then galvanized steel, and then insulation, and then a wood plug, and then replace the soffit. And then Tim can take down the temporary supports, and we'll open this place up to its fullest, reorganize our workshop, find a better place to put it, and commence to kitchen build. Okay, Tim's putting up hangers. And then we're gonna probably take the temp wall down on the left, and that'll make room for us to carefully lower the beam in the shores and these shores and get all this stuff out of here. Meanwhile, I got the pest block foam. Went up and applied it here at the end of the beam. Best situation I could sort of create. And just sort of stitch that shut and fill all the gappage, as well as over in here, which is a corner where, you know, somebody might make a home. And now I'm going to cut a square of galvanized sheet metal and fold it and apply it to where I can nail up here and try to nail up there, and just make that a hard surface and push into that foam as it sets up too, and just try to do what we can while we're here right now, while there's room to swing a hammer and everything else. Once it's put together again, I don't want to sit there and think of new things I could have done, because you're never going to take it apart to do them. So we'll do that, and then we'll put that wood up there. All right, I got that galvanized steel. If you buy it by the piece at the box store like Lowe's or Home Depot, it's $30-40 for a couple square feet of galvanized steel. I just flattened some stovepipe, which is the same stuff. It was like a $7.50 piece. Used half of it to build that, pinched it between two boards, bent a crease into it with a hammer, put some roofing nails up in there. I filled with foam first, and so now we'll insulate and put that wood plug in here. And then Mr. Wass can find another place to live. There you go. Plug that up real good. Insulated, steel, foam, wood, toe screwed. I'm gonna let it all just set up, because if you start messing with this, it will collapse like a cake does, and then you can have voids again. So I wanted to just set up, and then I'll carefully carve and also get rid of the drippage and all that next week, because I'm not on site tomorrow. I'm in kitchen design mode, so we'll do a sneak peek of that before we call this beam video episode done. So lucky you'll see that. But then that'll wait until next week on site, where I clean everything all up, make it look like it was never in there, straighten up that piece of channel for the soffit, and put the soffit pieces back up, pick the crap up out of the garden, and yada yada. But let's just see how this beam looks, right? Because that's like the whole point of this one. That's the whole point of, whoa, look at that. Look at that. Oh yeah, you've seen this part. Oh yeah, just the way you always wanted. So we just need the 2 layers here, and so we let this be more 2x6, because we're going to fur this out to be plainer. Probably put the same joist, or excuse me, stud layout in terms of rips that are the right thickness right onto this, so that we can apply drywall easily. Over here, we just need 1 rip probably along at the inside corner, because the drywall will, for the most part, be up and nice and flat by attachment to the beam, and then we'll just get the top edge into that other thing. No use in putting all these special sticks in on the stud layout, you know, famous last words. Yeah, probably won't. I cannot think of one possible reason why you would. You know, other than, you know, for example, in a weird situation, if you wanted a vertical outlet up there because, you know, you want to be able to, I don't know, put a shelf up there and plug rope light or something into it or what have you. You would be stuck with sticking a electrical box horizontally to the top of the beam or the bottom of that strip and whatever else, because we wouldn't have the ability to come out with a vertical box if that's what it was that you wanted. So I'll let that marinate over the weekend and make sure there isn't anything else, because I don't think that's likely, but to make sure there's anything else that is going to have me wishing that I had furred that out vertical, because you can always come back and do it, but then there are even shorter pieces that are annoying to nail, and they can break when you put them up with a nail gun, so then you're screwing them, and that's sometimes not even any better, whatever. So long story short, not exactly sure on all of that, but you know, Tim's learned a lot. He's been a great help. He did all this over here. He got just the 2 new pieces in, a layer of plywood over here. We kept lefty and righty original. He replaced the plate there, and we got the foam all in there. And this is really looking, we're gonna kick this into high gear now. So I'll give you guys a sneak peek of the kitchen that's going in this corner. Sink here, stove here, fridge over here, big old island there. So let's go back to HQ and check that out with a sneak peek, and then we're gonna wrap this thing. Okay, welcome to the little kitchen sneak peek, little sneaky little peeky. This is a plan view looking down from above over the kitchen sink area, centered on our new window, with our larger new window over here, with our smaller new window adjacent. And like I was saying, a stove in this region, the refrigerator over here right before the patio doors, and a big old kitchen island there in the middle. And this would be this elevation as you look at this. Looking through the kitchen island at the sink. Unfortunately, so the island has got 4 conventionally width but shallow cupboards on this other side where the countertop is cantilevered out right there inside in profile, for seasonal stuff or big awkward stuff. And so you know, I wanted some shallow storage there, and you can't have a drawer because when you pull it out, the counter's in the way. However, so then you end up with what is a floor to cupboard, you know, full door, unlike the rest of the cupboards with a drawer. And you end up with 4 seats, one centered on each door face here. And what I'm getting at is the seam between the pair in the middle doesn't fall on the center line of the window, which ends up being your viewpoint. If you take the island cupboards away and you look just in this area, everything's centered on that window there. So the 3/4 and stuff like that, you'll get that. And I don't want to get too far into the weeds here because it wouldn't be necessarily important for that to look perfect in the way that it doesn't. Let's open it up as a 3D model here. Ooh, we should view perspective with edges. There we go. There you go. And so we got, there's a few things suppressed here. The BEAMZ, let's turn that on. Sometimes I think I need to, why isn't that on? In the kitchen room itself, there lies extrusion, there it is. Unsuppress, finish. Okay, so now we can discuss and you can see more accurately where that beam that we've put in place. Now, it is shown all the same thickness here. Of course, we know now that this is almost 2 inches thinner on this face of it as a result of being only 2 layers. However, this will give you an understanding of, we're pretty close in accuracy here. We're talking farmhouse sink, couple of upper cupboards, maybe not that corner cupboard as much as some open shelving and a little bit of open shelving here. And so there's some things that are going to change slightly here, but you know, as we get inside, sorry, this is super touchy and I cut my finger today, so whoa buddy, take it easy. Yeah, there you go. So you got, like I say, oven on that side there. Now I think we're going to keep going here with coffee bar and drink cooler where you could have the creamer as well for the coffee bar, Keurig or the drip pot on top, and with a pot filler faucet on or over the stove. That's a quick and easy thing to fill the water rather than running back and forth to the sink. And then over at the sink, we've got dishwasher right, and so we could dishwash. And then these cupboards and the uppers slated for glasses and bowls and plates and silverware in these drawers. So then you can work out of the dishwasher on your left to the right again and to put everything away here. And then of course drinks, out of the fridge and what have you, leftovers, and making yourself a meal from the fridge can all happen kind of in this area, while a major sort of baking operation is happening on the island, or dinner is already set up on the island, or and what have you. Things get cooked and it's a la carte, or make your own, and all that stuff could be laid out here or adjacent if this is where it was prepped, cooked, laid out to be served, buffet style basically, right along here. Plates and bowls, turn around and eat, and then right back across into the sink and into the dishwasher and back into the cupboard. So we've got some pretty strong, sorry, that doesn't stop that from happening. We've got some whoopsie daisies, pretty strong workflow, which is the whole point of a well-designed kitchen. Sorry for the low fidelity navigation here, low tech navigation. That's what we're looking at. That's reusing their current refrigerator. That's accurate measurements on the oven they're going to use and the vent hood. Now that'll be clad to match things. It'll be finished, have a finished hood over it. I think we're talking about a big cove crown mold, and we've gotten away from another separate baker's bench, another surface here with butcher top, but I'm still kind of pushing for that. I think no matter what you do here, you could have cast concrete or stone, but it isn't as functional for rolling and flouring, because if you put flour down on that, it's all kind of come back up on the dough. You can't work it into the wood top and some other features of a bench top for baking and rolling and cutting and stuff like that. I'd really like to see that. Another thing that I mentioned to them is, if you think you might like some more surface and you can put butcher top on it as a special item with the rest of this, a different type of top. I think generally speaking, the whole production value of that kitchen space, you ratchet that up a notch. And she genuinely would use it, I think, and I think she'd really enjoy it. So I'm hoping to talk them into that. So this is where we're at right now, and we'll pick up here on the next episode. All right, everybody, thanks for watching. We'll see ya.